For 50 years, the marine industry agreed on one rule: diesel belonged inside the boat, and outboards meant gasoline. Yamaha walked away from the engineering problem. So did Mercury, Honda, and Suzuki. Every major manufacturer concluded a high-performance diesel outboard was impossible to build. Then a small Swedish company looked at the same problem and decided everyone else was wrong. The engine they eventually built consumes 46% less fuel than its gasoline competitors. It produces twice the torque. One commercial operator using twin engines saved $500,000 in fuel costs over 4 years. By 2026, the major manufacturers are running out of reasons to stay quiet, and the change that started in commercial fleets is reaching the rest of the industry. This is the story of the diesel outboard the marine establishment hoped you would never hear about. To understand why a diesel outboard was supposed to be impossible, you have to understand what the marine industry was building during the half-century it spent perfecting gasoline. When Mercury and Yamaha emerged as the dominant outboard manufacturers in the post-war American market, they made a series of engineering decisions that defined the entire category. The vertical layout, with the engine block oriented up and down behind a cowling, was designed to keep the powerhead above the waterline, while transferring rotational force down through a long drive shaft to a propeller below the surface. Gasoline engines fit this packaging perfectly because of their high RPM operating range and lighter weight. Diesel engines did not fit at all. Diesel powerheads were heavier, ran at lower RPM, produced more torque than gasoline architectures could match, and required different cooling and exhaust geometry to function properly. The vertical outboard layout was incompatible with diesel architecture, and every major manufacturer reached the same conclusion that if you wanted diesel propulsion on a boat, you put it inside the hull. For decades, this became the accepted wisdom across the recreational and commercial marine industries. Inboard diesel installations dominated the workboat market because diesel offered superior fuel economy, better torque for heavy loads, longer engine life, and the operational advantage of single-fuel logistics for fleets that already used diesel for trucks and equipment. But inboard installations consumed cabin space, required complex shaft drives and stuffing boxes, limited hull design flexibility, and made engine service substantially harder than swinging open an outboard cowling. Commercial operators tolerated these compromises because the alternative did not exist, and the marine industry assured them it never would. The market that wanted a diesel outboard was real and well-defined. Military fleets needed single-fuel logistics for amphibious operations. Commercial fishing vessels needed the torque to haul nets and the fuel range to reach distant grounds. Offshore wind farm support boats needed the operating hours that only diesel platforms historically delivered. Patrol boats and rescue vessels needed engines that would survive 24-hour operational cycles without rebuilds. The major manufacturers ran the numbers, looked at the technical challenge, and decided the market was too small and the engineering too difficult to justify the investment. Into this gap, in 2012 stepped a small Swedish startup called OXE Marine. The company name was taken from the Swedish word for ox, and the engineering approach was correspondingly stubborn. Where the major manufacturers had concluded a vertical diesel outboard could not be built, OXE proposed something different. Mount the diesel engine horizontally, the same way it sits inside a passenger car, and use a carbon fiber pulley belt system to transfer the power down to the propeller shaft. Skip the gear-driven drive shaft architecture entirely. Build the outboard around the engine, instead of forcing the engine to fit a layout designed for gasoline. The first OXE diesel outboard reached production in the spring of 2014, 2 years after the company was founded. The British competitor OXE Marine, founded in 2010, was working on a similar concept and brought their CXO 300 to full production in 2020, but OXE was first to market, and the diesel outboard category that the major manufacturers had declared impossible suddenly had a working product. Military buyers and commercial fleet operators were invited to test it against their existing gasoline outboards in real operating conditions, and the customers who agreed were about to learn that the marine industry had been wrong for 50 years. The first OXE diesel outboards entered commercial service quietly, and the early operating data immediately confirmed what the major manufacturers had been wrong about. The fuel economy numbers were the first metric to draw attention. A modern Yamaha F300 4-stroke gasoline outboard burns somewhere around 23 to 25 gallons per hour at wide open throttle. The OXE 300, running at the same horsepower output, burns 16 to 17 gallons per hour at wide open throttle. That represents a 46% reduction in fuel consumption for the same power output. verified by OXE's own testing and corroborated by independent commercial customers running both engines side by side. For a recreational boater, the difference is interesting. For a commercial operator running hundreds or thousands of hours per year, the difference is transformational. The torque figures were even more striking. The OXE 300 produces 945 Nm of torque at the propeller shaft, which converts to roughly 696 foot-pounds. A comparable 300 horsepower gasoline outboard produces approximately half that figure. Diesel engines produce their power at low RPM, which means the OXE reaches its full torque output at 2,250 RPM, while gasoline outboards typically need to spin past 5,000 RPM to deliver comparable thrust. For commercial applications, where heavy loads, slow-speed maneuvering, and bollard pull all matter more than top-end velocity, the torque advantage was a category-defining capability. Then the operating hours started accumulating. OXE rates the 300 horsepower outboard at 10,000 hours of expected service life, with service intervals at 200 hours rather than the 100-hour intervals typical of gasoline outboards. One commercial customer publicly reported logging 2,050 operating hours on a single OXE engine without major repairs, in conditions that would have required multiple powerhead rebuilds on a gasoline equivalent. The mechanical durability advantage was not theoretical. It was showing up in real fleets, on real water, in real maintenance logs. For commercial operators, the financial implications quickly became impossible to ignore. The owner of a commercial passenger catamaran calculated that switching from twin Yamaha F425 gasoline outboards to twin OXE diesel engines saved his operation approximately $500,000 in fuel costs over 4 years. A separate charter operator reported saving $150,000 per year on a single vessel. These were not marketing claims published by OXE to sell engines. They were operational figures from working businesses where fuel was one of the largest line items on the income statement. The customer base started shifting. Military fleets adopted OXE engines for patrol craft and amphibious applications because diesel fuel matched the logistics chains they were already running for ground vehicles. Commercial fishing vessels in Europe and the United States began repowering with diesel outboards because the fuel savings paid for the engines within 4 to 5 years of operation. Offshore wind farm support boats, which run continuous duty cycles servicing turbines miles offshore, found that diesel outboards offered the operational range and reliability their work demanded. The North American market alone now accounts for nearly 50% of OXE's revenue. But underneath the technical success, the cracks of a harder business reality were beginning to form. OXE was a small specialist company building a premium product for a relatively narrow market segment. The major manufacturers had decades of dealer infrastructure, parts distribution, and trained technician networks. OXE had none of those things at scale, and the price gap between a diesel outboard and a gasoline equivalent meant the customer base was structurally limited. The technology was working. The customers who needed it were finding it. But the path from validated technology to industry transformation was about to test the company harder than the engineering had. By 2025, the financial reality of disrupting an entrenched market had caught up with the company that built the technology nobody else would touch. OXE Marine's stock, listed on the NASDAQ First North Growth Market in Sweden since 2017, was trading at approximately 5 cents per share by mid-2025. The market capitalization had fallen to roughly $37 million, which is a small fraction of what a single Yamaha or Mercury production facility represents. Trailing 12-month revenue stood at $19,400,000. For a company that had pioneered an entirely new category of marine propulsion, those numbers describe a business that was running on technological credibility rather than financial momentum. The diesel outboard concept was working in the field. The company that invented it was struggling to translate that field success into a sustainable commercial enterprise. The structural problems were not hidden. A new OXE 300 retailed for approximately $60,800 in the United States, more than double the $25,500 price of a Yamaha F300. The math that justified that premium for a commercial operator running 1,000 hours per year did not work for the recreational boater who runs 100 hours per year. A weekend fisherman would save perhaps $4,000 annually on fuel, which means recovering the additional $35,000 in purchase price would take 9 years, longer than the typical recreational ownership cycle. OXE was selling into a market segment that was real but narrow, and the broader recreational market that drives volume in the outboard industry remained largely out of reach. The weight problem compounded the price problem. The OXE 300 weighs 871 pounds in its 25-inch shaft configuration, while the Yamaha F300 weighs 551 pounds. That extra 320 pounds per engine becomes nearly 1,000 pounds on a triple installation, and many recreational hulls cannot accept that weight without compromising performance, handling, or load capacity. Commercial vessels are designed with the weight in mind from the start. Recreational boats often are not, which closes off another segment of potential customers before the price conversation even begins. The dealer network was the third constraint. Yamaha, Mercury, Suzuki, and Honda have decades of established dealer infrastructure across the United States, with parts distribution centers, factory-trained technicians, and warranty service available in nearly every coastal market. OXE has built a smaller network of certified dealers concentrated in commercial marine markets, with parts and service availability that varies dramatically by region. A commercial fleet operator in Florida or Louisiana can find OXE service without difficulty. A recreational boater in a freshwater inland market may be hundreds of miles from the nearest qualified technician. For an engine that costs $60,000, that service gap is a real purchasing barrier. The marine industry watched OXE's struggle and drew its own conclusions. Mercury Marine eventually introduced a single diesel outboard model, but limited it to patrol boat applications. OXE Marine in the United Kingdom raised over $130 million in private investment to bring their CXO 300 to production, then ran into similar commercial limitations. The diesel outboard category had been proven technically viable, but the business case for scaling it into a mainstream product remained unresolved. The major manufacturers continued investing in gasoline platforms, calculating that the diesel market was not yet large enough to justify the disruption to their existing supply chains, dealer networks, and engineering teams. The result was a strange industrial limbo. OXE had built the future of outboard propulsion. Commercial customers were buying it. The technology worked exactly as advertised, and the company behind it was burning through cash faster than the market could absorb the price and weight trade-offs that came with the engineering breakthrough. To understand why a technically superior product can struggle to transform an industry, you have to understand how the marine outboard market actually works. The first reason the major manufacturers have not chased the diesel outboard category is structural. Yamaha, Mercury, Honda, and Suzuki have spent decades building manufacturing supply chains, supplier relationships, dealer networks, and service training programs around gasoline engine platforms. Pivoting any one of those companies toward diesel would require redesigning the manufacturing supply chain, establishing new technician certification programs, and competing in a market segment dominated by an established specialist. The economic case for that investment depends on how large the diesel outboard market is expected to become, and the major manufacturers have evidently concluded that the market remains too small to justify the disruption. The second reason is financial. The major outboard manufacturers generate significant revenue from the aftermarket parts ecosystem they have built around gasoline engines. Fuel additives, oils, filters, replacement components, and proprietary diagnostic systems all flow through dealer networks and produce recurring revenue long after the initial engine sale. Shifting customers to diesel platforms would cannibalize this established revenue stream without a clear path to replacing it at the same margin. From a corporate finance perspective, defending the gasoline platform is more profitable than competing for the diesel market. The third reason is the customer pyramid. The volume of the outboard market is in the recreational segment, where price sensitivity is high and weekend usage patterns make the diesel value proposition difficult to justify. The commercial segment, where diesel economics work, is a much smaller slice of total industry revenue. The major manufacturers optimize for the volume segment, and the volume segment does not reward the engineering investment required to build a competitive diesel outboard. OXE has been allowed to dominate a market segment the major manufacturers never wanted in the first place. But the analysis does not end at the structural advantages of the incumbents. Three pressures are now converging that may force the calculation to change. The first pressure is fuel cost. Marine gasoline pricing has trended consistently upward over the past decade, and the operational hour threshold at which diesel economics start making sense for non-commercial operators is now lower than it has been at any point in the history of the category. Recreational boaters with larger boats and longer use patterns are increasingly hitting the break-even point that previously belonged only to commercial fleets. The second pressure is environmental regulation. The OXE 300 running on HVO 100 renewable diesel produces a 92% reduction in carbon dioxide emissions compared to a gasoline equivalent, according to OXE's own emissions testing. As marine emissions rules tighten in European waters and increasingly in California, the regulatory advantage of diesel propulsion shifts from a technical curiosity to a competitive factor. The recreational customer who wants to keep boating without running afoul of future emissions rules now has reasons to consider diesel that did not exist a decade ago. The third pressure is operational range. A diesel outboard extends operational range by approximately 87% on the same fuel volume as a gasoline equivalent, which transforms the practical capabilities of long-range cruising vessels and offshore fishing platforms. Boaters who currently struggle with fuel logistics on extended trips, particularly in regions with limited gasoline availability, now have a propulsion option that nearly doubles their effective range without requiring a larger fuel tank. Each of these three pressures is independent of the others, and each is intensifying. The marine industry has been able to ignore diesel outboards because the major customer segments did not yet care enough about fuel cost, emissions, or range to pay the diesel premium. Each year, that calculation shifts further in the direction of diesel. The next decade of outboard propulsion will be defined by how the major manufacturers respond to the small Swedish company they spent a decade ignoring. Three outcomes are possible. A major manufacturer acquires OXE for its patents, technology, and dealer network. OXE survives as a niche specialist serving commercial and military fleets. Or a major manufacturer develops its own diesel outboard line independently, triggering an industry-wide pivot once the first competitor commits. The pressures making that pivot more likely are intensifying every year. Fuel costs continue to climb. Marine emissions regulations are tightening in European and California markets. Boaters running longer trips in bigger boats are reaching the operational hours where diesel economics become impossible to ignore. The major manufacturers can keep defending the gasoline platform, but each year that defense becomes more expensive and less convincing. The deeper lesson is about how marine technology transitions actually happen. The shift from two-stroke to four-stroke started at the edge of the industry and worked its way to the center. So did electronic fuel injection. So did the pivot from stern drive to outboard propulsion. Each transition was led by a smaller player willing to risk what the incumbents would not. And each transition eventually reshaped the market the incumbents thought they controlled. Diesel outboards may simply be the next transition in that sequence. The boat in your driveway today was designed around a gasoline outboard. The boat your kids buy in 15 years may not be. The only question left is which manufacturer will be brave enough or scared enough to lead the change.